Hello and welcome. Ever wonder how AI like ChatGPT can generate text that sounds so, well, human? Like what's actually going on under the hood?
It's a great question, and one a lot of people are asking. It seems almost magical sometimes.
Right. So today we're doing a deep dive into exactly that,
Yeah.
how ChatGPT and similar large language models actually work.
And we've pulled together insights from quite a few places, an MIT Sloan Talk with Ramakrishnan, articles from sites like kinzoo.com, sciencefocus.com, Wired.
BusinessDashReporter.co.uk, blogs like Palma.ai and DataCamp, OpenAI's own resources, and even Stephen Wolfram's breakdown. So a real mix.
Definitely. The goal is to get a comprehensive picture.
So our mission for you listening in is to demystify this whole process. We want to go beyond just the surface level and maybe uncover some surprising facts about how these things operate.
Okay, so let's start at the very beginning. What is ChatGPT doing at its absolute core?
Predicting the next word.
Essentially, yes. It's all about predicting the next word, or more accurately, the next token, which might be a whole word or just part of one. Think about a simple phrase like, the cat sat on the...
A mat, or maybe sofa.
Exactly. Or elementary, my dear.
Watson. Though apparently Holmes never actually said that exact phrase in the books. But the AI would likely predict Watson based on common usage.
Precisely. And the crucial thing to grasp is that the model, initially, was trained only to do this prediction task.
On just a staggering amount of data, right? Billions of sentences from the web from books.
Billions is right. For GPT-3, it was around 30 billion sentences. And GPT 3.5, which powers much of what people experienced early on with ChatGPT, was trained on something like 300 billion words, about 570 gigabytes of text data.
Wow. That scale is hard to even imagine.
It really is. And all that data allows it to build effectively a giant probability table. For any sequence of words you give it, it calculates the probability of every word in its vocabulary coming next.
So back to the cat sat on the mat. Might get, say, a 20% probability.
Right. And maybe fridge gets 5%, moon gets practically 0. It learns these probabilities from all the text it's seen.
And generating paragraphs is just repeating that process.
Pretty much. It predicts the next word, adds it to the sequence, and then uses that new sequence to predict the next word, and so on until it hits some kind of stopping point.
Okay, that makes sense. But why does it sometimes give different answers if I ask the same question again?
Ah, that's where sampling comes in. It doesn't always pick the single most probable word.
It rolls the dice, sort of?
In a way, yes. It samples from that probability distribution. The higher probability words are more likely to be chosen, but less probable, yet still plausible, words can also get picked. This introduces an element of randomness.
Which makes the output more varied and less robotic, I guess.
Exactly. Otherwise, it might always give the same, perhaps boring answer.
Okay, let's break down the name itself. GPT. What
Yep.
does that stand for?
Sure. G is for generative. It generates text. P is for pre-trained, meaning it was trained on that massive data set beforehand, not specifically for your question.
Right, that huge data set we mentioned.
And T is for transformer. That's the specific type of neural network architecture it uses, which turned out to be really effective for language tasks.
And there were earlier versions, GPT and GPT-2.
Yes, built on the same core idea, next word prediction, but with smaller networks and less training data.
One of the really interesting things about GPT-3 was these emergent capabilities.
Yeah.
Right? Things it could do that weren't explicitly trained for.
Absolutely fascinating. It wasn't specifically taught to, say, continue text coherently over long paragraphs or even recognize patterns like fix this poorly written sentence, but it learned to do these things just from the sheer scale of the data and the prediction task.
It just sort of figured it out from the patterns.
That's the current understanding, yes. It saw so many examples of coherent text, of corrections, that it implicitly learned those structures.
But those early models, like raw GPT-3, weren't great at following instructions, were they?
No, not really. You might ask it, write a short note to my neighbor asking to borrow some sugar. And it might spit out something completely unrelated, like a recipe for cookies or a history of sugar.
Because it was still just trying to predict the most likely text to follow your prompt, not necessarily understand the intent behind it.
Precisely. It didn't inherently grasp the concept of an instruction.
So how did OpenAI get from that to ChatGPT, which is much better at actually doing what you ask?
That involved a crucial multi-step process, primarily for creating GPT 3.5, the model that initially powered ChatGPT. There were 3 main steps.
Okay, what was step 1?
Step 1 was supervised fine-tuning. Humans actually wrote high-quality answers to specific instructions or prompts.
Like if the prompt was, explain the moon landing to a 6-year-old, A human would write a good example answer.
Exactly. They collected about 12,500 of these instruction answer pairs. This data was then used to fine-tune the base GPT-3 model, teaching it what a good answer looks like in response to a command.
Okay, so that's step 1, show good examples. What's step 2?
Step 2 involved creating a reward model. For a given instruction, the AI would generate several different answers. Humans would then rank these answers from best to worst.
Ah, so providing preference data.
Yes. They did this for about 33,000 different instructions. This ranking data was used to train a separate AI model, the reward model, whose job was just to predict which answer a human would prefer. It learned to assign a numerical score reflecting the quality of an answer.
Got it. So step 1, good examples. Step 2, learn to judge quality. What's step 3?
Step 3 is where reinforcement learning comes in, specifically reinforcement learning from human feedback, or RLHF.
RLHF, heard that acronym a lot.
Right. They use the reward model from step 2 to provide feedback during further fine-tuning. The main GPT model would generate an answer, the reward model would score it, and that score acted as a signal to nudge the main model's parameters.
It's like playing a game where getting a higher score from the reward model is the goal.
That's a good analogy. It learned, through trial and error, guided by the reward score, to produce outputs that humans tend to rate highly. They used about 31,000 prompts for this phase. This whole RLHF process was key to making the model more helpful, honest, and harmless, or at least more aligned with those goals.
And how did ChatGPT itself build on that GPT 3.5 foundation?
ChatGPT was then further fine-tuned, specifically on conversational data. Instead of just single instruction answer pairs, it was trained on entire dialogues.
Ah, so it learned the back-and-forth nature of a conversation.
Exactly. That's what enables it to handle follow-up questions, remember context within the chat, and interact in a more natural conversational way.
Okay, let's dive a bit deeper under the hood. You mentioned tokens earlier. What are those exactly?
Right, so when you type your prompt, say chatbots are helpful, the system first breaks that down into smaller pieces called tokens.
Are they always whole words?
Not necessarily. Chatbots might be one token or could be another, helpful another, but sometimes longer words get split, or common word endings might be separate tokens. It depends on the specific tokenizer used.
And then these tokens become numbers.
Yes. Each unique token in the model's vocabulary corresponds to a specific number. The neural network works with these numerical representations.
And the network itself is the transformer architecture we mentioned.
That's right. It's a complex web of interconnected nodes, or neurons, organized in layers. The connections have weights, or parameters. These are the numbers that get adjusted during training.
And there are billions of these parameters.
Billions! GPT 3.5 has 175 billion parameters. GPT-4 is rumored to have trillions, though OpenAI hasn't confirmed the exact number. These parameters encode all the patterns and knowledge learned from the training data.
You also mentioned an attention mechanism. What does that do?
That's a really key part of the transformer. It allows the model, when generating a word, to selectively focus on different parts of the input text. It helps it understand relationships between words, even if they're far apart in the sentence or paragraph.
So it can figure out what it refers to, even if the noun was mentioned much earlier.
Exactly. It learns to weigh the relevance of different words when predicting the next one.
Okay, so putting it all together, how does it generate a response, step by step? Let's say I ask, why is the sky blue?
Right. First, your question, why is the sky blue, gets tokenized into numbers. These numbers are fed into the transformer network,
which has its 175 billion parameters ready to go.
Yep. The network processes these input tokens using those parameters and the attention mechanism. Its final task is to output a probability distribution over its entire vocabulary for the next token.
So it predicts what word is most likely to start the answer. Maybe the or because.
Probably something like that. Let's say it predicts the with the highest probability. It then takes the, adds it to the sequence, and feeds the whole thing. Why is the sky blue? The back into the network.
To predict the next word after the
Exactly. Maybe this time it predicts sky. Now the sequence is, why is the sky blue? The sky, feed that back in, predicts is, feed that back in, predict blue, and so on.
One token at a time, building the answer based on probabilities learned from its training.
Precisely, until it predicts a special end-of-sequence token or reaches a length limit.
And the randomness, the temperature setting, where does that fit in?
That affects how it chooses the next token from the probability distribution. A low temperature makes it pick the most likely words almost all the time, more focused, maybe more factual, but potentially repetitive.
At a higher temperature.
A higher temperature increases the chances of picking less likely words. It makes the output more random, more diverse, potentially more creative, but also increases the risk of it going off topic or making less sense. It's about finding the right balance.
So why does it often sound so convincingly human? Is it just the massive data?
That's a huge part of it. It learned the patterns, the style, the cadence of human language by reading billions of examples of human writing.
And the fine-tuning helped, too.
Definitely. The RLHF process specifically trained it to be helpful, conversational, and follow instructions in a way that aligns with human preferences. It learned politeness, how to structure explanations, that sort of thing.
But, and this seems crucial, it doesn't actually understand things the way we do, right? It
Yeah.
doesn't know facts.
That's the critical distinction. It's all based on statistical patterns learned from the data. It predicts what word is likely to follow another word in a given context. It doesn't have a world model, beliefs, or true comprehension.
Which is why it can sometimes hallucinate.
Right.
Make things up, but state them very confidently.
Exactly. If a sequence of words sounds statistically plausible based on its training, even if it's factually incorrect, the model might generate it. It doesn't have an internal fact checker based on understanding.
There's that chef analogy that sometimes comes up. Can you walk us through that? How is ChatGPT like a chef?
Yeah, it's a useful way to think about it. Imagine the pre-training phase, reading all that text. That's like a chef reading every cookbook ever written, absorbing recipes, ingredient combinations, cooking techniques.
Okay, learning all the patterns.
Right. Then the initial attempts to predict the next word are like the chef trying to recreate recipes from memory, maybe making mistakes, getting some feedback, internal adjustments.
Getting better with practice.
Then the fine-tuning, especially the RLHF part where humans rank outputs. That's like having human tasters come in and say, we prefer this version of the dish, or make it a bit less salty. The chef adjusts their style based on these preferences.
Making it more palatable to humans.
Exactly. So now, when you give ChatGPT a prompt, make me a dish that's like lasagna but with chicken, the chef doesn't invent from true understanding, but draws on all the learned patterns and preferences to assemble a new dish, the response on the fly, combining elements in a statistically probable, generally pleasing way.
But the chef doesn't fundamentally know why cheese melts or why certain flavors work together chemically.
Precisely. It just knows the patterns that lead to successful dishes based on what it's seen and the feedback it's received.
Stephen Wolfram has a slightly different but related perspective, focusing on just adding one word at a time.
Yeah, Wolfram emphasizes that fundamentally it's always just trying to produce a reasonable continuation of the text so far, based purely on the statistics learned from its massive training corpus. It's always asking, what's a plausible next word here?
He also talks about embeddings, this idea of representing words in a meaning space.
Right. Embeddings are a key concept. The neural network learns to represent each word or token as a list of numbers, a vector in a high-dimensional space.
And words with similar meanings end up close together in this space.
That's the idea. Through the process of training, like predicting the next word, the network figures out these numerical representations so that words used in similar contexts get similar vectors. King might be close to queen, running might be close to walking. It captures semantic relationships numerically.
So the network isn't just working with arbitrary numbers for words. It's working in a space where the geometry reflects meaning, in a sense.
In a sense, yes. It's how the network implicitly handles meaning without explicit definitions.
So wrapping up, despite how impressive this all is, there are limitations.
Oh, definitely. As we said, there's no true understanding or consciousness. It can generate incorrect information, it's susceptible to bias present in its training data, and it doesn't perform complex multi-step reasoning reliably. It's not doing irreducible computations in the way Wolfram might think about them.
And future directions might involve trying to bridge that gap, maybe incorporating more structured knowledge or symbolic reasoning.
That's a major area of research. Combining these large language models with things like knowledge graphs, symbolic AI, or computational languages could lead to more robust, reliable, and truly capable AI systems.
Okay, this has been incredibly insightful. Let's try to summarize the key takeaways for everyone listening.
Sure. So, at its heart, ChatGPT is a highly sophisticated next word prediction engine.
Powered by a massive data set and a complex transformer neural network architecture.
Critically, it's been fine-tuned using human feedback, RLHF, to make its responses more helpful, coherent, and aligned with what people want.
But even though it seems incredibly intelligent, its abilities stem from identifying statistical patterns in language, not from genuine understanding or consciousness.
Right. It's pattern matching on a massive scale.
Our goal with this deep dive was really to peel back the layers and give you a clearer picture of the mechanics behind this fascinating technology, hopefully providing some aha moments.
And maybe a final thought to leave you with. Considering that ChatGPT has implicitly discovered so many regularities and patterns in human language just by trying to predict the next word, what truly fundamental laws of language or even laws of thought might still be out there, waiting to be explicitly understood and formalized? The success of these models suggests there are deep structures we haven't fully grasped yet.
That's a fascinating question to ponder, something to think about long after this conversation ends. Thank you so much for breaking that all down.
My pleasure. It's a complex but really interesting topic.
And thank you all for joining us on this deep dive. We hope you found it informative and intriguing. Until next time.
Goodbye for now.